The first project I ever did on this channel was called Privacy Ninja. This was a program that used a motion sensor to close tabs or a program on your desktop computer. This program worked pretty much exactly how I wanted to, and I even went ahead and made a small enclosure to keep the device a little bit more contained. I wanted to expand on this project by making it a little more accessible and a little bit more reliable. In this video, I'll show you how I did that by creating a DIY door switch. If you'd like to see, stay tuned. Also, if you just want to see the final product, then you can skip ahead to this timestamp. So what we have here is the Raspberry Pi with one wire connected to the 5-volt GPIO pin. What my hopes are is that if I connect the other end to the input GPIO pin that I set in the code, which was pin 11, then the same response as if somebody walked in front of the motion sensor will be triggered and a signal will be sent to the server. If this is the case, then all the code that I wrote previously will work, and the only thing I'll have to change is the wiring. So here's the basic setup. I have my Privacy Ninja server set up so that it will close the Firefox window here when motion is detected by the Raspberry Pi. I'm then connected to my Raspberry Pi through SSH. My Raspberry Pi just has the Privacy Ninja client software cloned onto it, which you can get through GitHub or at my website. Now I'm going to run the Privacy Ninja client software. Now that the client has started, I'm going to test just connecting the pin to pin 11, which is the 6th one. And okay, it said transmitting data, and it worked, and the Firefox window closed, which is great. That's actually exactly what I wanted it to do. So that means that I don't need to change any of the software. I only need to change the wiring. So right here I have a door and a door frame. Typically on door frames there is a small lip around the door frame that prevents the door from going further than the door frame itself when you close the door. I plan on utilizing this small lip to create some sort of switch that will trigger the pin 11 on my Raspberry Pi, as shown before. This switch will be created from this aluminum tape or some aluminum foil. Here's what the setup will look like. On the top of this door frame, there will be 2 pieces of aluminum foil. This piece will be connected to 5 volt, and then this one will be connected to pin 11. What's important to note here is that there is a small gap right here that prevents this circuit from closing. Then, on the door, there is one piece of aluminum foil that is not broken up. However, this is not connected to anything. When the door closes, this circuit is completed because this piece of aluminum foil will bridge this gap and have it make the circuit run to pin 11, powering pin 11. This will call for a small change in my code because unlike before, a signal will need to be sent when the pin 11 is not charged, rather than before where a signal was sent when pin 11 was charged. I will also have to make a small tweak to increase the cooldown time of the sensor so that it doesn't continuously send signals when the door is just left open. This is a very simple system and hopefully it'll be adequate. Before I do anything, I just want to check if these 2 things can conduct electricity. I'm pretty sure they can, but just before I do anything, I want to check. Using the resistance function on my multimeter, I was able to determine that both of these materials were capable of conducting electricity. The aluminum tape was pretty strong, so to not ruin any of my walls, I connected the aluminum tape to some painter's tape that would be wall safe. Just cut 2 small strips of the aluminum foil and I put it on the lip of this door. Now I just gotta do the same thing for this, the actual door, not just the frame. And now I got all of the metal pieces on the door. I need to find a way to connect 5-volt to this one and pin 11 to this one. I'm probably gonna have to like strip a wire or something so I can get it thin enough to fit in the gap between the top of the door and the bottom of this shroud. I realized something. There's a gap between this back and this shroud, so it won't be actually making contact when the door closes. I'm probably gonna have to like put something in between here to make this a little bit thicker. I'll get back to you when I find out how to do that. Okay, well I found a quick fix. I just used some putty and it works. Now when I close this door, it makes direct contact right there. Just using some Scotch tape, I was able to actually connect up these wires to these two terminals, and hopefully just using some extensions I can connect this to my Raspberry Pi. Now I'm going to test if the door switch thingy actually works. So I haven't changed any of the code yet, but in its state right now, when I close the door, the Firefox tab I have open should close. So let's start by running the client software. And now that that's set, we're gonna close the door. Oh, yes. Okay, so it works. Yeah, so the Firefox tab closed, and now it's just continuously transmitting the signal because the door is now closed and the circuit is also, the switch is now also closed constantly, and will only be started again when I open the door, which I can do right now. And yeah, now it stopped cycling. So now I just need to make a small tweak in my code and it should work perfectly. I made a few changes to my code to make it run for this situation. For one, I changed this current state variable to check for 0 in this if statement, so that the program triggers when the door is opened instead of closed. I then introduced this reset variable, which prevents the program from continuously sending signals when the door is kept open. To implement this, I reset the variable to false when the signal is sent, and it is only reset to true when the door is closed, or when this else if statement detects that the current state of the door is 1, or when it's closed. And that's pretty much it. This should be exactly what I need for this system to work. So let's go test it out. So let's start by running the client software. Okay, that's set up. Now I'm going to open the door and see if the Firefox tab closes. Perfect, it closes. Okay, looks like the system isn't continuously sending data, so I think the reset system is working. Let's just check it by closing the door and then opening up a Firefox tab and then opening the door again. It worked. Okay. Yeah, I think that's about it. I think that gets the job done. I think this was a really good project. I only needed to change the code a little bit and I created a pretty much brand new project. I didn't even need to change the server-side code to get this implementation working. In comparison with the other method, the motion sensor method, both have their benefits and downsides. For the motion sensor, the device can be placed pretty much anywhere, even across the house. This gives you a little bit of a time buffer and also allows you to hide the device pretty much anywhere, which, depending on your use, can be very helpful. For the door switch method, this method, One benefit is that it's really cheap and accessible. The materials for this, which are just some aluminum foil, some tape, and some wires that can be salvaged from like a spare USB cord or something like that, can be accessed by pretty much anyone. Another benefit of this method is that it may be more reliable than the motion sensor. In contrast to the motion sensor, where it can be placed in a way that someone can walk around it without triggering any motion, this door switch can basically not be worked around because it's connected directly to the door. The only real issue that I see with this implementation is that it's really easy to see. Not only are the electronics like the Raspberry Pi and the battery bank externally visible right on the door, but also the pads that create the switch are visible to anyone looking from the outside. This can actually be improved on though if you use a different type of switch and you extend the cables and hide the electronics somewhere else in your room. However, I don't think you'll ever get to a state of containment and invisibility as the motion sensor has. Either way, I think that this is a great project, and if you have a Raspberry Pi, I think you should definitely try it. All of the files that I used in this project will be linked down below in my GitHub. If you liked this video, feel free to like it or even subscribe. And yeah, that's pretty much it. Thanks for watching.